going to Sarah Perry. And Sarah Perry says this: Hello, StarTalk. Climate change has been a huge discussion for a while now, and I keep hearing scientists and politicians say that we're approaching a point of no return. I don't know why I said that like William Shatner. I don't know. A point of no return. Anyway, we need to act now, is what they say. My question is, what exactly is the point of no return? Are we actually close to the point of no return? And what is close anyways? What is the tipping point for a major climate change? And how much time would that tipping point take to completely change our atmosphere and our weather? So...
yeah, what's up with tipping points, Kate?
I'm detecting a very distinct skepticism in Sarah Perry's question.
No, I get a total apocalyptic state of concern there. I read that differently. It's
All
like,
right.
is it a tipping point? Are we there yet? When is it going to happen? What can I do about it?
Okay,
it was because it has a kind of manic flavor to the rapid sequence of questions.
I see that.
All right, what you got, Kate?
Well, I think what's important to know is that we're already experiencing the effects of climate change now. So the planet has warmed, and along with that, we're seeing heat extremes. We're seeing increases in wildfire. We're seeing changes in our in precipitation and in water cycles. And what the science shows is that as warming continues, those will increase. So we will see more changes in temperature, more heat extremes, an increase in the proportion of intense tropical cyclones, more wildfire weather. And so we'll see more and more of that as temperatures rise.
So you're not thinking of it as a tipping point as much as we're just entering the gates of hell. And but I think the tipping point implied that no matter what we do, we'll never reverse it.
Right, and there are some parts of climate that are irreversible. So things like ice sheet melt and sea level rise. Once an ice sheet melts, it's irreversible on the timescales that we're typically talking about. So it could take centuries to millennia. There are other impacts, though, like the heat extremes that are reversible. If you can bring global mean temperature back down, you would reduce the heat extreme again. But it depends on the impact, whether it's reversible or not.
I hadn't thought about that. There's a difference there, because if you melt ice, you're not remaking that ice because we're not in an ice age, right?
Exactly.
So you raise the water level, that you're stuck with that. But everything else, maybe we can get a handle on. Okay.
What if we got 10 million battery operated refrigerators with ice makers?
That would work, Chuck. I'm sure. Yes. Okay.
I would need to do some more math on those numbers.
Do math on that, Chuck, before you bring that to the table. And it just pumps out the ice cube
It
out
just
the
keeps
back.
shooting out ice cubes. Just
They did it in the Beijing Olympics. Those mountains didn't have any snow on it. They said, let's bring in some snow and some snow makers. So, all right. All right.
Well, Sarah, there you go.
But Chuck, you got to remember, there's no free ride in the world of thermodynamics. Right. So what you needed energy to make the ice that your refrigerator was punching out the back door.
Right. So even battery operated or solar powered.
Oh, solar would work.
Okay.
I think solar. So, yeah.
So solar powered.
You'd put them where there's very little sun, which is in the polar regions. You're not kidding.
There you have it. Yeah.
I keep working on that, Chuck.
Here's what you're saying.
What?
Think this through, Chuck. Go ahead.
I think it needs some research. Yeah.
Do a little more research on it.
This with Mason. Mason says
Mason didn't even give you his last name because he didn't want you to try to pronounce it.
I think his last name is Jar. So
Mason Jar. Okay.
God, what a dad joke that was.
That was so.
God, that was so.
That's right.
Like, yeah.
But
like,
you are a dad, so that's legit. It's legit if you actually are a dad.
If you are a dad, right?
Right,
yeah.
right, okay.
I actually heard my children just go, "Man, stop, stop it, bro." Okay, here we go. What are NASA's plans to combat climate change? Are there any long-term, short-term plans in regards to the rising levels of greenhouse gas emissions? I've read interesting things on huge towers filled with moss plants that could help filter the air. Is this something NASA may be helping with?
Wow.
Look at that.
Yeah, so I think, so Kate, isn't this on the scale of geoengineering? I mean, there's a whole other concept there. So other than give us data about what we're doing bad, and possibly advising on what we should be doing. What is in the power of NASA to actually fix this?
Yeah, that's a great question. So NASA, first of all, we observe the Earth from space. So we can provide data that helps inform decisions about climate change. And we've been doing this for decades. So we have a long array of data about things like vegetation or carbon dioxide or temperature to see how Earth is changing. In terms of how to reduce and to mitigate climate change, NASA has two roles in this. One is we do climate modeling, so we can understand what the effects are of different emission scenarios in the future. The second is we actually develop technologies that can help mitigate and adapt to climate change. So we have a sustainable aviation program that has been working on reducing fuel use and emissions from airplanes.
Making them more efficient in all ways, I guess, aerodynamically as well as their engines. And I just got to interject there. Correct me if I'm wrong, Kate, but your climate group in NASA is based in New York City. Is that correct?
The climate modeling group is based in New York City at the Goddard Institute for Space Studies.
Goddard Institute for Space Studies. And they are over the restaurant that's featured in Seinfeld. The building that houses that restaurant contains the Goddard Institute. Am I correct about that, Kate?
Yes, you are.
All right.
What's the deal with climate? Who are these people?
So this is encouraging. But how about these concepts of like Moss towers or carbon dioxide scrubbers out of the atmosphere? Is this still science fiction?
Well, I think when you talk about removing carbon from the atmosphere, there are a number of different techniques in there. The most common one would be planting a tree. And so planting...
What a concept!
We've been doing it for a while.
Why didn't I think of that?
Society. But yeah, trees take carbon out of the atmosphere, and that is one way of reducing carbon. I think NASA's role in this is really on observation. So we can actually look at the trees and measure how many trees we have, how they change over time. We also measure carbon dioxide, so we can monitor how that changes over time.
So a biological question, since you brought up trees, is a tree the most effective plant that can remove carbon? Is there something that we could be planting in addition to or other than trees that would actually pull out more carbon?
Good question.
It's a good question. It's a complex question because it depends on the type of tree, where you're planting it, what was there before. And so the effect of a planting of a tree on carbon depends on a lot of factors. Trees also change the way the Earth's surface reflects energy. So where you plant those could also have an effect, not just from their carbon removal.
So isn't it true that it's not good enough to only think about the carbon dioxide in our atmosphere, because the ocean has something to say about this, doesn't it?
Yeah, that's important. So the ocean absorbs quite a bit of carbon. So when we emit carbon into some of it goes into the ocean, some goes into the land, and some stays in the atmosphere. Oceans also uptake heat. And so they play a really important role in climate change, both today and how that changes in the future. And so the more we can understand the oceans, the more we understand climate.
But if I pull CO2 by whatever magic way out of the air, the ocean says, oh, wait, I can give you more CO2. Isn't that right?
Well, there is a balance in that. So when you you move carbon from one pool to the others will respond until they reach an equilibrium.
Okay.
Oh,
yeah.
Wow.
Okay.
Look at that.
So you can take it out of the air, and the ocean said, here's some more.
Right.
You ain't getting away that easily. You put it in here to begin with. I'm just giving it back to you. I think that's that dialogue, right? Right.